Namaskar. So let's try to understand how we can take PWM output from a microcontroller pin. Okay. So we have the microcontroller MSPM0L 1105, and our aim is to identify which pin are capable of giving PWM outputs, and then we will take out those outputs, right? So example I have given you here, but first we will try to understand how to identify those pins, right? So let us open datasheet. And once you open datasheet, in features itself you will see that we have like 4-bit general purpose timers, and each timer are capable of like capture and compare modes, and a total of 8 PWM channels are also there. Okay, so PWM capability is there for this microcontroller that we have understood, right? Our target device is already, we are working with 20 pin VSSOP, so that you have to keep in mind. Okay, next, once we proceed to as you can see here, timers. So we have two channels, Z0, Z1, Z2 and Z4. Okay, so total 8 channels are available. Now we have to identify whether each of the timer channels are capable of giving the PWM outputs in our 20 pin VSSOP package, yes or no. Okay, so what we have to do is we have to go to the table of content. Okay, and first try to identify which pins are capable. But before that, shall we do one thing? We will go to timers and we'll try to understand what is the capability of the timers. Okay, so once we go to the timer, we can see we have a specific features for general purpose timers. Okay, which is GX, which is G0, G1, G2, G3, G4, right? Not G3, G4. So we have 16-bit timers up and down, 32 bits, then 8-bit programmable pre-scaler is there. Okay, and it has a capability of output compare, input capture, PWM outputs. Okay, and one shot mode. So that you don't have to worry about like what are all these things. Our aim is to get a PWM output whose waveform will be varying, okay, based on the duty cycle that you will mention. Okay, so this is what we are going to decide. So let's say if you want to have a 50% duty cycle, the high and low width both will be same. If you want to have, let's say, 25% duty cycle, high will be 25, low will be 75%. What is PWM output? That you guys know, right? Let us say 50% all are there, this is also same, so this will be 50% duty cycle. Okay, now if you want to have 25% duty cycle, it means high will be 25% and low will be 75%, then again 25%, 75%, so this will be 25% duty cycle PWM. Okay, so this is the basic understanding of PWM outputs. If you want to have 75%, then what will happen? High will be 75% and low will be 25% of that. Okay, so this is how it will be 75% duty cycle. Understood? It means T on time divided by T on plus T off. That is your duty cycle. Okay, like on time divided by total time period. Now our understanding should be T0, T1, T2, T3, T4, right? And you can see we have PWM channels. Each one of the timers are having two channels. All right. So that's all. This was the understanding of PWM, availability in the microcontroller. Now we will proceed to our, pin identification. So let's go to pin attributes. Once we go to pin description, we will have to find out which pins are capable of what timer, right? So you can see we have the capability of timer 1, timer G1 C1, and timer 2, like timer G2 C0. So it is very difficult to identify like this, that how to work on these pins. Okay, so as I have already suggested you, we will go ahead with our signal descriptions. Okay, so in signal descriptions you will see all the functions are put together. So ADCs were all put together. Similarly, timer will be also available with us. Okay, so let's search for timer. Here it is. So as you can see, we have timer G0 C0, timer G0 C1. So what we will do is we will try to take out PWM from these two, and these two and these two. Since our aim is to identify VSSOP 20 package, so this is the like target device. So our aim is to understand whether all the timer, like all the PWMs are available or not. So see, we don't have this timer available, okay? So what we will do is we'll try to take out complementary PWMs like C0, G0, C0 will be like positive side, and G0, C1 will be negative side. Okay. So let's say we'll have 0P, 0N, let's say 1P and 1N. So let's say 1P, 1N, and let us say 2P, 2N. So these will be total 6 outputs that we will take, and we will take output from here also one more channel. Okay. So this will be our understanding. Now let us move to the identification here. Okay, so I have pasted here, okay, the PWM outputs, and we'll try to see a application of this PWM. Like, why do you want to have 6 channels of PWMs? So as you can see, any like 3-phase motor driver, you need to have 6 PWMs. Like one will be like positive and then complementary of that. Similarly, this and this and this one and this one. So 3-phase. So total 6 PWM will be needed for you, okay? And each of them will be complementary to each other. So 3 pairs will be required. Understood? So that's the reason I am going to take out 6. Now let us try to consider this one. We will try to find out 0P channel and 0N channel, okay? So you can see pin number 12 and 18. So let's try to analyze 12 and 18. So pin number 12 is this. So I have assigned here PWM 0P. 18 you can see it is like V reference. So it can be utilized for internal V reference pin. So that I am not using. So I have assigned 0P here. Okay. So one PWM assignment for the microcontroller pin is done. Understood? So I have remodified the pin configuration of this microcontroller for other functionalities. I have deleted them, and I am going to work with PWMs only. Okay. Next, going back, 0N I will assign pin number 10 and 19. So let's search here. Pin number 10. The 10 is used as like LED user 3, user LED 3, and 19 is here. So you can use either 19 as well as pin number 10 both. So I have utilized uh, PWM 0N. So one pair is complete. Similar to that, you have to go here and see for 1P and 1N channel. Okay. So I can take a pin number 1 and 4. Out of that I have taken pin number 1, and pin number 2, 5, 8 I have taken pin number 2. So 1 and 2 I have taken for 1N and 1P. Okay. So you can see 1P I have taken pin number 1, and 1N I have taken pin number 2. So another pair is also complete. It's very easy to identify this way. Now we will go ahead with this one. Let's say we are going to go for 2P and 2N. Okay. So timer G4 C0 will be positive channel. Timer G4 C1 will be complementary channel. So I am going to take pin number 13 for this, and here pin number 11, 14 and 20, out of that one of them. Okay. So let's go to the circuit, and we will see pin number 2P and 2N, that is 13 and 14. Okay. So pin number 13 and 14 I have taken for pin number 13 for this, and pin number 14 for this. Let us say one more PWM is available in this, like pair is not available, but this one is available. If you want, you can have one extra PWM. So I'm going to take pin number 17 for that. Okay. So you can see pin number 17 I have taken as PWM 3. So this is how we have total 7 PWMs. Okay. And you can easily drive your like 3-phase motor driver, which requires like full bridge drive. So for that you need to have 6 channels of PWMs, and you can easily drive using this very low cost microcontroller. However, one thing I want to point out here is, since this is a microcontroller of just 20 pins, okay, Out of that, around 6 to 7 pins you are utilizing in PWM itself. Okay, so for that purpose, other functionality you may require some of the GPIOs or maybe ADCs or some control signals. So for that you may be having, like very less number of pins available. So I'll suggest you, if you are going to have a need of 6 PWMs, okay, so in that case you go ahead with 32 pin package of the same family, MSPM0L 1306. Okay, so 1306 will be having 32 pin and it has the better capabilities as well, and there you will have total 8 PWMs also. Okay, like one channel was missing, right? You can see one channel was missing here, here, so you can see 32 pin package, this is also available. Okay, and you have better flexibility, almost so many pins are having same timer outputs. Okay, so this is how it will be more useful to go ahead with this 1306 package series, right? So this will be 32 pin VQFN package. Okay. That's all. So hope you have understood how to identify a PWM pin, and like how to assign for PWM outputs of a microcontroller. Now calculation and all those things is very easy. While designing the circuit, designing the embedded software, I'll teach you how to like vary the frequency of PWM outputs, duty cycle. Like you need to have PWM parameters. Let's say what is the frequency that you need, what is the duty cycle that you need. Okay, so all these things that will be discussed in your embedded tutorials. All right, so if you do have any questions regarding identifying the PWM pins in a microcontroller, or how to identify whether the microcontroller is capable of giving a PWM output, okay, so those things can be very easily identified. If you have any questions or anything, you can put down those questions in the comment box, and I shall be able to help you out in that regard. However, since I suggested you one more thing, this 32 pin, is used for, three-phase motor drive. Now, suppose you need only one PWM to drive one, a very small, low cost, low power, motor driver, let's say BLDC driver from Texas Instrument. So for that, you can still go ahead with this microcontroller where you may need only one PWM. So you can use PWM3, and you can drive that signal. So these are basically used to either dimming the light, so this will be used in your LED driver or something. At the same time, reducing the current through the you know like I mean motor. So motor current, if you want to reduce, there will be a pin where you need to have PWM input, which will help you to reduce or increase the current output. So for that purpose, this only single PWM will be utilized for that. Okay, so if you are going to use only one PWM, this microcontroller is best suitable. Okay, all right guys, thank you